Hi, I'm John Crandall. You've seen me in such fine quality, epic physics educational videos such as Canu, Physics, Chapter 9, Work, and Canu, Physics, Chapter 9, Spring Constant and Power. Today we're going to be looking at energy. So, energy, it's the ability to do work. There's two basic kinds of energy. There's kinetic and potential. In kinetic energy, it's moving energy, okay? Slapping the neck, that's an example of kinetic energy. Volleyball spiked by a lancer, Canu dropping the mic, all that. So here's our formula. Ke equals 1/2 times the mass times the velocity squared. Okay, let's get into some problems here. Now our kinetic energy is going to be in joules. All the energy, including work, is also in joules. So we're going to calculate the energy of joules in one of these bullets from a .30 caliber rifle. So here we have a mass and we have a muzzle velocity. A muzzle velocity is the moment that the bullet exits the barrel of the gun that it is being shot out from. Okay? So let's go ahead and let's work with this. So we have 0.5 multiplied by our mass, which is 0.00972 kilograms. Now, here's the thing. We have to keep it at kilograms because remember, when we're working with the energy, we have to keep the units like kilograms and meters and seconds. We have to keep that. Because if you do it in grams as opposed to kilograms, your numbers are going to be off. Okay? And we're going to multiply 703 meters per second. And we're going to square the 703. So I'm just going to write it again. Now, do you have to do it this way? No. You could just simply put the little 2 up there to say, hey, it's squared. So let's check this out. Okay? So I have 0.5 times 0.00972 times 703 times 703. And I walk away rounding. I have 2,402 rounding joules of energy from that bullet. Okay? So this is the 1/2. This is the mass. This is the velocity, and because we square the velocity, we do that again. So 1/2 mass times velocity squared, which is what we did here. And we have 2,402 joules. Okay. Now, when you look at the second problem on this, which we're not going to do, I'm going to leave that as one for you guys to work on, you'll notice that the muzzle velocity is definitely greater than the original. So we would expect the kinetic energy to be more than it was coming out at 703. Let's move on here. We do have something called the work energy theorem. And the idea is we have final kinetic energy minus the initial kinetic energy. So we look at the change in kinetic energy. So what we're going to do, we're going to calculate the change in kinetic energy in joules of a 2,000 Newton truck traveling at 20 meters per second as it slows down to 10 meters per second. Now we know that kinetic energy is 1/2 mass times velocity squared. Do we have the velocities? Why, yes we do. We have one here, and that's going to be our initial velocity. That's where the truck was traveling at when it was starting. And then we have another one here where we have our final. So we have our initial, we have our final there. So we're good to go on that. But we also have to look and say, well, wait a minute. We don't have the mass. It didn't say anything of kilograms because the mass needs to be in kilograms. You're right, but they did give us this piece of information that it's 2,000 newtons. Well, wait, what do you mean a 2,000 Newton truck? Is that like the force? Well, we do use newtons for force, that's true. But the reality is there is the force due to gravity. Yes, the force due to gravity. So what does that mean? Well, force due to gravity is equal to mass times the acceleration of gravity. Now the acceleration due to gravity is 9.8 meters per second squared. Okay? So what we're going to do, we're going to take the 2,000, we'll put that up here, and we're going to divide that by 9.8. Okay? So we have 2,000 newtons, and we're dividing it by 9.8 meters per second squared, and that's going to give us how many kilograms is the actual truck. So 1, 2, 3, divided by 9.8 equals, and I go with about 204.1 kilograms. So we're going to go with that, 204.1. That doesn't weigh a lot. But what we can do, we can now go ahead, and what's our final kinetic energy? Well, it's 1/2. Okay, remember, kinetic energy is 1/2 mv squared. So why don't we go and do this? We can go ahead and say, you know, it's true about the KE final and the KE initial. They both have the 1/2. They both have the mass. So why don't we do this? Why don't we go ahead and say 0.5 multiply by our mass of 204.1 kilograms. So we have that. All right. Now the v squared. So this is where life's going to get interesting. Because what we're going to do, we're going to take the initial, the final minus the initial. So we're going to take our final velocity squared here, and we're going to square that. So we're going to say 10 squared minus 20 squared. So all this, we don't have to square it. You need to square the velocities first. You can't say 10 minus 20 and then square it. You cannot do that. You will get the wrong answer. You have to square each velocity. Okay? That's a very important thing. It's an easy mistake to make, but you've got to square it. Square the 10, square the 20. So the 10 is going to be 100, 10 squared, minus 400, which is 20 squared. Now you'd say, but wait, that's going to get us a negative number. You're right, and the negative is telling us the truck is slowing down. That's where the negative comes in. The negative is not a bad thing. It's telling us, hey, the truck is slowing down. All right, so now we got 0.5 times 204.1 times negative 300. Okay, so we're going to look at the change in kinetic energy. Here we go, 0.5 times 204.1 times 300, and it's negative. So I get, for my final answer, I get negative 30,615 joules. That is the change in kinetic energy of the truck slowing down. Okay? So that's the change in the truck slowing down. All right, guys. Let's go on back here. Okay, I was almost successful. Okay, let's move on. So let's look at this one. The next kind of energy we're going to look at is potential energy. This is, in physics, potential energy is based on position of the object. And when we look at it, we're looking at specifically gravitational potential energy. In other words, the potential energy you get based off of how high are you up and the effects of gravity. Now, in chemistry, you do have a potential energy like potential chemical energy like you would have in a battery that you haven't used. Where we go, we rely on a calculator, but it has batteries on the back that we would rely on. Okay, but that's chemistry. You can check out my chemistry videos elsewhere. Pachow. Okay, I wanted to do that. So potential energy, stored energy. Our formula, potential energy is equal to mass in kilograms times the acceleration due to gravity times how high the object is in meters. That's it. So let's take a look here. So we have a sleepy dog. named I Can See You, mass of 15 kilograms, on top of a cliff that is 60 meters high. What is the sleepy dog's potential energy? Well, so we know that potential energy is equal to mass times gravity times height. So in this case here, this is a very simple plug it in. We have our mass, right? 15 kilograms based off of that. We have our G of 9.8 meters per second squared. Now, notice they didn't mention the 9.8 in the problem. This is something that we assume you would know, and you do have the constants to work with. And then the H, well, they told us it's 60 meters high. So what is the sleepy dog's potential energy? So 15 times 9.8 times 60. And we walk around ahead with 8820 joules of energy. That's what the dog has. Okay? Now let's go ahead. We'll quickly work through this second problem. I'm checking my time. I can do that. I should be able to do that because the last problem, that's going to take a little time, and that's going to require another video. So here, Joey is helping Jeff lift up a 25 kilogram box of books from the ground to a shelf that's 1.5 meters from the ground. So we have ourselves a mass, we have ourselves a height. What is the gain in potential energy? Now, the idea is, guys, that the box was on the ground, and then the box gets lifted 1.5 meters. So when they're talking about the gain in potential energy, you're just calculating the potential energy here based off of the formula mgh. So that would be 25 kilograms multiplied by 9.8 meters per second squared multiplied by the 1.5 meters. So we're doing very similar to the previous problem, okay? So we have the mass, so 25 times 9.8 times 1.5, and we walk away with 367.5 joules. And that's our answer. That's the gain in potential energy that we have lifting this box of books. Okay? Alrighty, let's move on. Okay. This, again, is the same type of problem. Okay? And again, it's the same type of problem here. Okay? So with that, guys, I'm going to stop here. You've looked at kinetic energy and potential energy. Kinetic energy is the moving energy, kind of like how I'm moving my hand on my neck, okay? Because I'm Jonathan Crandall. Then there's potential energy, where it's the energy depending on your mass, the acceleration due to gravity, and how high are you up. All right, take it easy. Have a good one, and I'll catch you on the flip side.